Hello, everybody, and welcome back to day 2 of the API Days Hong Kong Conference 2022. Today we have a bunch of interesting talks lined up for you, and I want to take a quick reminder before we get going to check out the Partners Village and support our sponsors. Now, without any further ado, let me introduce our first speaker. First up, we have Mary. She's a senior streaming developer advocate at DataStax.
Hello.
Hi, Mary, can you hear me?
Yes, I can hear you, Simon. Thank you.
Perfect.
Yeah.
Loud and clear. And today, Mary is going to talk a little bit about leveraging event streaming to supercharge business solutions.
Yeah.
And without any further ado, I'll hand it right over to you.
Thank you, Simon. I appreciate. Yeah, thank you. And thank you, everybody, for coming to my talk. And I understand that we won't have too much time, so I'm going to try to hurry and squeeze in as much as possible. So yes, and as such, thank you to Simon for having introduced me. But I want to also first ask or let you know that if you want to access the slide deck, this is the bit.ly link for that, as well as the QR code. So I'll leave here for like 10 seconds if you want to take a quick snapshot of this. And then even if you miss it, do not worry about it, because I've already shared the link with the conference organizer. So I'm sure that somebody can also be sharing that with you. And also too, I'll be giving you my contact information, so you can reach me directly as well. I can always have conversations with you one-on-one too, that I welcome. So, all right, without further ado, let me start. I'm Senior Developer Advocate at DataStax. We are a company that's based in the US, in California, but all of us actually scattered everywhere, about 600 people, this company. We are a leading data management company. We specialize in database as a service, so NoSQL, big data, and now also streaming. Also, all of our products are very highly available, open source Apache projects, Apache Cassandra for the database side, and Apache Pulsar, which I'm going to be talking about. Previously, I was a Java developer advocate at IBM for about 3.5 years. I'm based in Chicago. I'm also a Java champion and also president of the Chicago Java Users Group and a couple other users group in the Chicago area. Before this, too, before becoming advocate for 4 years, I was actually a developer myself, doing engineering work for over 25 years, primarily in Java, but I also work with other languages too. So I can kind of understand too, let's say if you are a developer, I can understand very well the situation that you face every day. So, okay, so let me start. Again, you know, I'm a Java champion. All of these things I think are already listed out, but basically I'm an advocate. I do less of focusing on development now, but I come out and do outreach work and talk about the products and really wanting to bring the excitement of all of these things to you, for example, like audiences like you, and answer any questions that you have and kind of spreading the word and sharing with all of you. So that's me. And okay, so let me quickly start. So today's, I'm going to give some background about, you know, my topic is about leveraging event streaming. So I want to have a quick introduction about ironing out, right, the terminology of what event-driven systems, event streaming, event processing, all of these terminology. I want to clarify that, make sure we're on the same page. There's also the distributed messaging side of things that are kind of closely related to events, but not exactly, just slightly differences. And then I'll talk about the event processing semantics, right? Pops up, publish, subscribe, and queuing. And then also, like, how can event streaming actually improve your systems, right? And why do you want it? And also then introduce you to Apache Pulsar, which is an open source project. And Pulsar is a streaming platform that's kind of catered for the cloud native environment. And then also, I will also be introducing to you that Pulsar also relies on 2 other Apache open source projects called Zookeeper and Bookkeeper too. And then I'll highlight a couple of developer features that are specific for Pulsar. And then also, again, why Pulsar, right? And all these things. So yeah, so hopefully it's like a quick introduction for you and get you all excited and wanting to learn more about it. Let's say if you haven't already done it, right? So, okay, let's start. So many facets of computing events, right? So I wanted to kind of point out, kind of bring to your attention, what is an event, right? Like generically speaking, right? And then it can mean different things to different people kind of thing. But when I look up the dictionary, I think that's fair enough, right? To say, event without any specific context, it refers to something that just happens, an occurrence. So here we are in the IT world, technology world, we're dealing with computing events. And essentially too, if we kind of look at the list of all the definition, and I found out the fourth point in here that I took from Merriam-Webster.com, is really coming from the theory of relativity. It's basically pointing to the fact that events is what we try to capture. The physical reality, right, that of an event is essentially represented by, the 3 coordinates of place. So that would be, if you are math inclined, it is the X, Y, Z coordinate. So that only explain this point in time in space. But the thing about events is that it also has a 4th dimension of time. And that's what makes things very, very interesting. If you are kind of processing data in huge quantities, especially events, they keep changing, the state keeps changing, the data itself doesn't always stay the same, right? Usually there are some changes and then the state change and value changes, all of these things. So that's one kind of present a lot of challenging and also fun things, for computing to kind of deal with this kind of scenario. Basically, is dealing with 4 dimensions, X, Y, Z coordinate and the change of time, or the time that brings on all the changes in these data. So that's event. So now then gets into event streaming processing. It is actually it's really practice of taking action on this series of data points, right, that originate from a system that continuously creates data. So the event refers to each data point in the system, and the stream is referring to the ongoing delivery of those events. So a series of events can also be referred to as streaming data or data streams. And of course, in these days, right, when we are watching movies online, these are also streaming. And of course, these are also data that that are being delivered to your devices. They are come in, huge quantities like that. Those are also streaming too. So streaming data, the data itself can be audio and video. Also although there are some differences in which if you're dealing with audio and video systems, if you're a programmer, there's just different ways of having had to handle it because of the nature of that kind of audio media streaming. So that's just something to point out to you, but we're not going to go into detail to talk about that today. And okay, so now then moving on, from just regular event streaming processing, there's also complex event processing, this terminology. What is referring to is really a set of techniques, right, to capture and analyze these streams of data as they arrive, right? And the purpose is to identify opportunities or threats in real time. So think of a scenario in which, perfect candidate for using event streaming would be fraud detection system. And the nice thing about doing things the event-driven way is that you do everything, you get your data, you can immediately process it and analyze it and derive some conclusion and value out of that streams of data that you're looking at, right? And again, right, it can be fraud. And for example, like fraud detection, you have bank account, right? And of course, nowadays too, banks are very sophisticated. They have different monitoring kind of services behind the scenes, and those are perfect candidate to use like events kind of processing type of capability to basically handle and watch for your data. Any kind of unusual activities in your bank account, you need to be notified right away, right? So that's the key. And that's what event-driven system, event processing, event streaming type of process system can kind of deliver to you, is that immediate real-time analysis and immediate result that can be, that it can be used to notify you that something is wrong. You don't want to wait, right? Something like that. You want to react to it right away. So basically, too, it help you to respond to events and trends. So fraud detection is one thing, but you can also be like a shopping experience, making recommendations, that type of stuff. That can also be utilizing an event-driven, event streaming type of systems too. So okay, so basically, responding to the data as they happen. And now there's also event-driven versus message-driven messaging. So there are differences too. Event-driven is basically we're talking about the sender is emitting messages, right? And it doesn't really care about who is going to be receiving the messages. I'm only responsible for producing the messages. And so it's up to subscribers that are interested in those messages. They will subscribe to those messages accordingly, and then they will receive messages when the messages gets produced by the producing side, right? So that's event driven. And then there's also message driven. It's basically sender and receiver of messages will have to know each other, and the address therefore too will need to be known to the sender, so then the sender knows where to send the messages to. So those are kind of the differences. I just want to kind of point that out to you. Okay, so then now we're looking at event-driven approach, and that's actually not new. This is something that's been kind of, being used, in the industry by computing, by telecommunications, for quite some time, as we know. And then you might wonder too, like what else, if we don't use event approach, what would it be? But in fact, a lot of things too are also being done in batch, right? And for example, like your employee system in a big company, you want to make changes to it, you update your employee information, you want to process it maybe at a later time. Basically, too, all of these change of data will be gathered up and be processed in the later part of the day, so that it doesn't take up, valuable processing power of your machine during the daytime. When the daytime, you need all these processing power to kind of like operate on data immediately, that type of stuff. So, okay, so that's kind of a quick difference. So now, again, going back to the fact that we're leveraging, right? This is an API conference. We're leveraging on event streaming to kind of supercharge your business. So you may be wondering, how can it do it, right? So essentially, too, event-driven messaging, right? There are also the semantics, the patterns. And I brought up already a little bit about event-driven, but let's kind of get a bit into it. It's basically the streaming aspect of it is enabled by this design pattern called PubSub, publish and subscribe. So essentially, too, that pattern will isolate, right, or separate out your sender of messages, decouple it, right, the sender, the producer, and kind of separate out from the receiving side. So the benefits of such is that you can actually scale really well, because you can have tons of messages being sent, and we rely on this broker, like the middleman, middle person, right, to be kind of managing. There is a serverless process that takes in all the data and will process it accordingly. The broker is sort of like the middle kind of agent to do things for you. The publisher just comes with this whole bunch of messages and said that I want to label these messages as a topic, for example, something like that. So the broker will then deliver the messages accordingly when the messages comes, and the publisher doesn't have to worry about it. And then on the client side, or kind of receiving side, all I need to do is to subscribe to that topic. So then when data comes, then the broker would deliver the messages over to the client. So that's actually a really big plus, because it helps really, again, in scalability. You don't need to worry about memorize all the addresses, right? You're letting the broker handle all of it. And in a cloud system too, in fact, you can have many brokers too that are handling all of these different topics, and you can have tons of messages coming in, and you can scale up and down easily. So it helps with scalability and the manageability of your system too. So that's the kind of advantage. Another approach too, besides like PubSub, right? PubSub is a architectural pattern. You can also have a pattern that's called message queuing. So queuing also, you separate out the sender and the receiver. But the difference is that messages arrives at a message queue, and then once it gets picked up, right, by the subscriber, or it gets sent over to the subscriber, then the consumer, then the message will get removed from the queue. So that's kind of a difference between that and PubSub. It's more a point-to-point system. So both have their own advantages and their usages too, essentially. And then now let's kind of take a look into event streaming. It's a step beyond just the messaging aspect of it. And what is driving this change, right? So in today's world, we want everything to be done quickly. We want to have real-time data system, right, to handle all of the demands that are coming in. So real-time, this kind of enabling real-time analysis and processing, that's kind of one reason why we want to use event-driven type of approach. And then there's also like artificial intelligence machine learning pipelines, for example, data pipelines, these can actually be leveraging on event-driven, event processing, streaming type of approach to kind of ingest high volumes of data. And then as data comes in, as we all know, AI and machine learning systems, you need to constantly be analyzing your data and updating your models to at the same time, and deploy your model as is being changed, right? So it's very dynamic system. So you can certainly be considering to use like event streaming data pipelines to help you to build that kind of capability. And another thing I already talked about is basically being able to scale your system to meet the demands of large volumes of data coming in that are generated by application operating at the edge. So that's what it is. So here I won't repeat it. I have more things to talk about, which is Apache Pulsar. So Apache Pulsar is an open source project created by Yahoo back in like the early 2010s. At that time, cloud, computing, cloud native was just starting to come out, and Yahoo was already ahead of time. And they realized that at that time, any kind of message queuing systems and PubSub, whatever it is, just wasn't able to handle the load that is required to operate, these huge amounts of data ingesting, being ingested and being able to respond to it quickly. And what they have at that time maybe more like MQ systems, queuing system, the older message-oriented systems, or Kafka was just coming out. But Kafka's the design is that it's not kind of kept like the cloud native aspect in mind. So Yahoo developed their own system and call it Pulsar. It basically takes on a cloud-native design. It's already cluster-based. It's multi-tenant. And the nice thing about this is that, well, you don't necessarily have to be a Java programmer to use it, right? The broker itself is written in Java, but basically you can write, produce a client in your language of your choice. And right now there's C#, so .NET and Python and Go. There are also community contributions that, for example, like Scala, Ruby, all of these other languages too that you can use for writing clients and basically talking to the broker. And on your receiving side, you can have completely different languages written. Let's say you have a Java producing client, then you can go through the broker. You can have .NET client to be the subscriber too. So that will also work. So making it very flexible. And also messages gets delivered kind of a guarantee too. So that aspect is very important in this type of messaging system, because otherwise then messages just get sent. It can be easily kind of falls through the crack and not be delivered, right? But Pulsar has this built-in mechanism to guarantee delivery too. And then another aspect of Pulsar is that it also has a functions framework. It's serverless, very lightweight. And so if messages are transferring, over your pipeline, you want to do transformation, for example, something you want to filter out some of your data, you can actually use a Pulsar functions, that library, to kind of help you to do that too easily without you having had to build your, to kind of integrate with other types of library. It works kind of similar to Amazon, their streaming Lambdas platform, Google PubSub, or Google functions type of framework. So it's the same kind of principle too. And then one more thing about Pulsar is that it's got a tiered storage offloads too. So as we all know, right, all the data coming in and data, sitting in a topic waiting to be picked up, whatever it is, and it becomes cold, right? It's taking up a lot of space. So Pulsar has this built-in mechanism. It will move all of these cold kind of like data that's waiting in there. It's cold and move it off to long-term storage and things like that. So making you, the developer, very kind of less work to kind of less thing to worry about essentially. So, okay. And let me kind of make sure I have enough time. Maybe just kind of keep 1 more minute. I just wanted to talk, just talk a bit too about why Pulsar is essential to the modern data stack, right? And also letting you know who else is using Pulsar. All of these kind of companies and organizations too are already heavily using Pulsar too. So Pulsar is different. I already talked about all these things. And I mentioned too, basically, about also Bookkeeper. Bookkeeper is the one that manages all the tons of messages that comes through your system. You need a way of persistently store these messages and consistently making sure that it is correct data. So Bookkeeper is the Apache open source project that Pulsar uses. So then Pulsar doesn't have to worry about it. It delegates over to Bookkeeper to take care of things like that for him. So, and then there's also Zookeeper, essentially helps in a cloud native cluster environment, manages all of the metadata, manages all the tasks between the different clusters as well. So that's what Pulsar leverages on. And let me see. And then some things I wanted to point out is essentially too, this kind of approach is nice. I call it supercharge your business solutions, because very often too, you have scenarios in which you have a lot of data. You need to scale your system, and all of the topics are carrying all of the data, maybe in different partition, right, of your whole ecosystem. And what if you add another node on another cluster to your system? Then you will need to kind of basically reorder all of your topics and rebalancing all of your topics and all of these things. And guess what? Pulsar is already built with this cloud native kind of thing in mind. It knows how to actually rebalance all of your topics, all of your partitions, essentially. So making your job as a developer much easier, that you don't have to worry so much about it. So horizontal scaling is becoming easier is what it is. Okay, and let me kind of really quickly too, before I get to this, I again wanting to point out the key differentiator, basically the benefits of using Pulsar as your event streaming, is basically it has separated out the compute and storage, right? So you make scaling essentially a lot easier, the horizontal scaling part especially. And then also there's a feature called Geo Replication. For large companies, you might want to have different data centers to organize all of your, your data being spread out, all of the messages that are coming in. So the Geo Replication is actually a very powerful mechanism in Pulsar, in which it knows how it can replicate all of the data from one data center to another without you having had to worry so much about this type of maintenance infrastructural type of work. And then another feature is called multi-tenancy. It's essentially too, you have data, you want to organize it in different tenants too, it's called. So then, for example, right, an example of a company, you can have finance department has their own namespace of these topics. And then you get a marketing department has becoming another tenant, and yet another tenant. They all kind of live and basically organize underneath the same Pulsar cluster. So Pulsar already has this capability too. And then one more thing is about very flexible message processing model. So basically too, you have messaging, kind of producing the messages, you have subscribing side. If your subscription is called a exclusive subscription type, then it allows message queuing too. So if you want to kind of use Pulsar as your message queuing kind of mechanism, you can use this exclusive subscription, and that would turn it into a message queuing kind of capability too. And then there's also failover subscription, shared subscription, and want to point out key shared is essentially lets you have the messages being processed in the order, being delivered in the order that it's being received to. So if you want to keep the order of all of your messaging. So Pulsar itself is actually quite kind of capable in that sense. So, okay. And I'm not sure if I still have some time. Let me kind of making sure. Okay, so I think I was told too, I may not have enough time. So just really, really quickly too, a couple new features I wanted, or not new, but the data pipeline, there's also Pulsar function that basically think of all of your data travel through from the source over to the sink, right? So it makes it kind of very easy to kind of do development in this sense. Pulsar functions, again, is lightweight, function as a service kind of idea, transform your data as it travels through the data pipeline. And another thing is a Pulsar schema too. It basically allows you to not worry so much about the type of the data, and it manages the type changes too, essentially. So in a summary. And another thing is called Pulsar I/O. I mentioned about this data pipeline. You can actually have different sinks. You can have Kafka sync, you can have RabbitMQ sync, you can have Elasticsearch sync. So making this kind of a connection really easy, and you can write your own connectors too. So with that, I won't kind of spend as much time, but just DataStax too, we have Astra streaming, Luna streaming, and open source if you're interested in, the Pulsar capability in the event streaming aspect too. Also, let me kind of really quickly now, kind of give this, okay, I won't have time to demo, but wanting to give you a sense of, the resources if you want to look it up. And over here, AstraDB.com is the one that I would like to invite you to sign up for a free cluster usage, $25 US every month for free. You don't need your credit card. Sign up for astra.datastax.com to try out our managed cloud. And then also we have 5 minutes about Pulsar. If you want to know more about it, we are now doing this on the YouTube on our channel that we kind of explain all of these concepts to you in small kind of 5 minutes chunks. So make it easily digestible. And then please follow my Twitch stream every Wednesday at 2 p.m. US Central Time if you can. If not, you can always look up the recording too. I talk about different, kind of topics. I chat and do some live coding as well. And then join us at the Hood. And basically we have Meetup that's kind of talk about Pulsar, and also Pulsar Neighborhood is a vendor neutral ground. You can participate and contribute articles to that too. And with that, I want to thank you very much. And this is how you can reach me, my Discord server too, my Twitter handle and LinkedIn. So thank you very much. And I hope I'm like just in time. So yeah, okay.
Just in time, Mary. Thank you very much for your engaging presentation. And I think we all learned a lot about
Thank you.
And event streaming. And I also thought it was nice to see that you have a Twitch channel, and that hopefully more people can check it out and learn. Unfortunately, we are out of time, so no Q&A this time.
Okay.
But again, I want to thank you, and I want to wish you a pleasant, and I hope you enjoyed making your presentation. Thank you, Mary.
Thank you, Simon. Thank you, Rose, behind the scenes. Thank you to all the organizers. Okay, take care, everybody.
All right. Bye-bye, Mary. Thank you.